Before we move on to a new lesson, let's just revisit writing equations in function form. As I was reviewing the homework, I saw this needed a little bit more work. Our goal is to isolate y in terms of x. What are we doing? We're writing it in function form. In particular, we're writing it into slope-intercept form. Y is equal to mx plus b. We'll start this problem off with subtracting 3x on both sides. Our goal again is to isolate y, and by doing that, we have successfully done so. But I want to stress that when you're writing this, you put your x term before your constant. That was one thing that stuck out as some of you were miswriting the final form. Second problem, let's go ahead and add 4x to both sides. As I'm writing this, I will remember to put my x term before the constant. There's one more step. I need to divide all terms by 2. My final function form looks like y is equal to 2x plus 3. Let's take a look at a third problem. Inverse operation tells me to subtract 7x. When I cancel this out, notice I'm left with negative y. This is familiar to you from yesterday. There was a similar problem in our classwork. We're not solving for negative y, so we'll divide everything by negative 1. And what does that do? It changes all the signs. Here's 2 steps to isolate my variable. Let's subtract 3x on both sides, leaving me with 4y on the left. Again, my x term comes before the constant, negative 3x plus 8. Lastly, let's divide all 3 terms by 4. Y is equal to a negative 3/4 x plus 2. Last review problem. Let's go ahead and subtract 5x on both sides. Canceling out leaves me with a negative 8y is equal to negative 5x minus 6. If we divide all terms by negative 6, I will get y is equal to 5/6, positive 5/6 x plus 1. And that's a quick review of our function form. I hope that was helpful. If we need to see more, please ask in class today. So we move on to lesson 3.8, rates, ratios, and percents. They've chunked a lot of topics in one short section. We're going to start off with our rates. They are quantities that are measured in different units. Miles per gallon, dollars per pound, cost per person. All of those are rates comparing 2 different quantities. When I want to compare to one, that's called a unit rate. It's $6 for 1 pound. It's $12 to rent for 1 hour. So we're thinking about comparing something to one. It gives me a unit rate. Here's a couple practice problems. Let's find the unit rate. Now I wrote the words unit analysis because we need to be able to tell me, am I solving for money or cans of tuna? Am I solving for the dollar amount or the number of pens? Always look to see what are they asking for. Well, they're asking us for the unit rate, and if it costs $4 for 5 cans, all right, there's my ratio. It's a 4 to 5 ratio. Then how much does it cost for 1 can? I could set it up as a proportion, but technically that's just a division, because I would get 5x is equal to 4, and then I would divide both sides by 5. So go ahead and divide and find out, and round to the nearest cent if it needs to. My next problem is telling me that there's a package of pens that's $4.50 for 9 pens. I wonder what the cost is for just 1 pen if I could only buy one. And we call this the unit rate. Again, one more problem here, $234 for 6 hours. What is the cost for 1 hour? We're dividing to get our unit rate. What does it cost for 1? Here we might see something in the form of a word problem. You want to rent a car while you're away for a 5-day vacation, and the rental agency charges you $340 for that 5-day rental. What would it cost if you only rented it for 1 day? Another word problem, if a plane flies 1,420 miles in 4 hours, find the distance traveled in 1 hour. We're again doing a division to find what it costs for 1. We'll go over the answers to these last couple problems in class. On to today's problem. In today's topic, we're looking at also ratios. Ratios are comparison of two numbers by division. It could be written in one of 3 ways. Looking at the 3 ways, we could have the word 2, a 6:7 ratio. There might be a colon between the 2, which is still read 6:7, and it could be written as a division 6:7 as well. We can write ratios in lowest terms the way we would write a fraction in lowest term, by dividing by the GCF. I could take these ratios, and again, it can be written in one of 3 ways, but what if I take it and write it now in this form? It reminds me of how I simplify fractions. Divide by the GCF, which is 4. This is a 3:4 ratio. We always write our ratios in lowest terms. Don't change the order. This is a 24:8 ratio. When I simplify, divide by the GCF, it's a 3:1 ratio. Don't simplify because a ratio is a comparison of 2 terms. I have now 36 and 10. Divide by the GCF, I get 18:5 ratio. And there are 2 more for you to try. And we'll check those as well during our session. If we're taking these ratio and comparing 2 terms, there is something that we need to know. We can simplify a ratio the same way we simplify a fraction, and we're also going to find out that 2 ratios that are equivalent or equal form a proportion. So you may be asked to solve a proportion by using cross multiplication. Before we get to the solving for a missing term, let's just check to see if we can find out if these 2 ratios form a proportion. We're going to do that by cross multiplying. We're going to take the extremes, which are these 2 terms, 6 times 12. And then we're going to find the product of the means, which is 9 times 8. Well, I get 72 on the left, 72 on the right, so these 2 ratios are a proportion. We can do 2 different things. We can simplify both and see if they come out to the same fraction, or we could just use our cross products. And we get our 4 times 7. Does that equal our 6 times 6? Well, 28 does not equal 36, so these ratios do not form a proportion. Sometimes you'll be asked, do they form a proportion? So these ratios do not. And how do I know? I did my cross products. If the cross products are not equal, not a proportion. Now, the last thing I want to do before I end today's session is look at finding a missing term. Again, we're going to use our cross products property. We're going to multiply 6 times x and our 9 times 10. That will give me 6x is equal to 90, and I'll divide both sides by 6. Now again, I want to keep my answer in a decimal form. I'm going to divide, and 9 will go in there once with 3 left, 3 left over, and that will be 15. X is equal to 15. That's the missing term. Again, let's cross multiply. Let's multiply 6 times x and 4 times 12. Looking for a missing term, 6x is equal to 48. Divide, and x is equal to 8. We can do this even with some distribution involved, but I'm going to stop here and give you some time to practice.